So our objective today is to understand and solve coin and value problems. Okay, and we call this coin problems because we're literally going to talk about a whole, pocket full or jar full of change made up of different types of coin. And what I mean by value is we're talking about how much something costs. Like you could buy several of the same kind of stamp or the same kind of clothing or something like that. Okay, so these two problems, we're going to use a chart, but we're going to use the chart a little differently this time. Because to get the answers to these types of problems, we actually need to use a formula. Now, most of you haven't memorized these as unique formulas. You just inherently understand how to solve these problems. So, for example, Target has these super cute little mini heart pillows right now. They have pink ones and they have red ones. And they cost $7 each. I have 5 friends I want to buy them for. Without tax, how much money am I going to spend on those pillows? How'd you get 35?
So 7 times 5.
Okay, you took how much it costs for one, by how many I want to buy, and I got the answer. That's a formula that you inherently know. So that would give you this. The quantity, which is how many, Josh, we're taking notes, times the price of one. Let's make that a little more clear. Equals a total cost. Well, in a sense, okay? So what I'm going to outlay has to deal with how much does one cost and how much does it cost to get all of the ones I want to get. Armand.
What about tax?
Okay, right now, let's pretend I'm in Nevada and I don't pay sales tax because the gambling pays for it. Okay? Now, let's talk about another one. Again, this is one that most kids figure out. So you have a babysitting job and you charge $5 an hour because the kids are sleeping and there's not much work for you to do. And the parents are gone for 4 hours. How much money do you expect them to pay you?
$20.
How'd you get that?
5 times 4.
Yeah, you took how much money you get per hour times how many hours you worked, and there comes your income. So that's the second formula that you guys have worked with, and you just kind of inherently understand it. So number of hours worked times the, let's see, pay per hour equals your income. What money do you expect to come in from that experience? Okay? So we are going to do 2 problems, and I'm going to switch to the next screen so that we'll have a clean screen. And I'm going to show you how to use the chart to how it morphs for this type of problem. Mr. Pratt, you with us today? Because you're staring everywhere and you're not writing anything. Okay. So, next screen, everybody good? Except for Pratt, he's going to have to catch it with somebody else. So, we have to write this. Problem 1. Bill ordered some small and some medium pizzas for a party. The small ones cost $3.75 each. And the medium ones cost $5 each. He bought 3 more medium than small pizzas the total cost was $32.50. How many pizzas of each size did he order? Okay, so chart-wise, it's going to start off like yesterday's. We're going to have the two unknowns go vertically. What are the two unknowns in this one? Yeah, we have two different types of pizza. We have a small pizza and we have a medium pizza. But we're not going to put across the top age now, age then, blah, 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 because we're not talking about that. So we're going to go back to thinking about those formulas that we talked at the top. So what we have is quantity, so how many of each kind of pizza, and that's what we're being asked to solve for. So I'm going to let S stand for small pizza and M stand for large pizza. Now I'm going to give you, and you'll see in a minute, why S may not always be the best variable to choose, and I'll show you why in just a second. And then we're going to have the price of one, and that's going to be, for the small was $3.75 each, and for the medium it was $5. And then we're going to have cost. So if you think back to that formula, we're going to multiply the quantity times the price of one to equal the cost. So what I have for the cost is going to be 3.75 S and 5 M. Okay? Now, what is missing in this problem, a huge number that they gave us that doesn't show up anywhere in our chart? Emily L? Or Emily S, sorry, yeah. And where would that go, Emily? Where at the end? So it's supposed to go over here? Okay. I have to make a new column for it? I don't think I want to make a new column for that. Lexi? Yeah, basically what I could do is just put it right here. That's what these two add up to equal is 3250. So basically what we've just created is our first equation. So 3.75S plus 5M. So the total cost for the small pizzas plus the total cost for the medium pizzas equals the total cost of $32.50. Okay. Now, going back to why I said sometimes S isn't the best variable, sometimes if we don't write our S very well, it's going to look like another 5. So be very cautious with what you choose as your variable so you don't get confused. Is that a number? Is that a variable? Okay. Now, I have two unknowns in this problem, so that means I need a second equation. So I need to go back through the problem and see if there's something else that I could translate into an equation. So the first sentence just gives me generic information that some pizzas, small and medium, were ordered. The small ones cost $3.75 each, and the medium ones cost $5 each. We took care of that in our chart. He bought 3 more medium than small pizzas. Okay, that I could do something with. So now I have to think, what does it exactly say? He bought 3 more medium than small pizzas. So what does he have more of? The small or the medium pizzas? He has more mediums. So in order to make the small get up to the same level as the medium, we have to keep them separated. And so the medium number of pizzas is the small number of pizzas with 3 more added to it. Okay? So now, which technique have we learned solving systems is going to work best for this one? No? This is a perfect one for substitution. It's going to go in right there. So I have 3.75 S plus 5 times the quantity S plus 3 equals 32, and I'm just going to write 0.5 because I don't need that extra 0. All right, So one of the things I really don't like dealing with is decimals. So I want to get rid of my decimals now. What am I going to need to multiply everything by in order to get rid of all of them? Armand?
10.
10 won't take it around the 3.75. It'll only take it to 37.5, and I'll still have a decimal.
100.
So I need to go to 100. So I multiply everything by 100. So now my equation is 375s plus 500 times the quantity s plus 3 equals 3,250. So I distribute and I get 375s plus 500s plus 1,500 equals 3,250. So I do notice I have some like terms right here with my s's, and I'm going to go ahead and subtract 1,500 from both sides to get the constants together on the right. So I'll continue over here. And that adds up to equal 875s equals, what is that? 1750. I divide both sides by 875. And I get S equals 2. Okay? That's how many small pizzas that he ordered. To figure out how many medium, I'm going to plug that value into the easier of the two equations. Oops. And I get M equals 2 plus 3, which equals 5. So my final answer is Bill ordered 2 small and 5 medium pizzas for his party. Now I can always check this by figuring out, well, if medium is 5 and I bought 5 of them, how much money is that?
$25.
Okay, so this is $25. And if I bought 2 pizzas that were $3.75 each, how much money does that add up to? $7.50. And if I add those together, I get exactly what I'm supposed to get, $32.50. All right, so the next one is a coin and value problem. David has some nickels. Dimes and quarters. Uh-oh. What does that make you think? How many unknowns?
3.
Wow, 3. Worth $4.50. That's something we have to watch out for. So how many equations are we going to write? We have to write 3, one for every variable, okay? Otherwise we won't be able to solve it. He has 3 times as many nickels than dimes. And 4 more quarters than dimes. How many of each kind of coin does he have? So 3 unknowns means I need to come up with 3 equations, because I can't solve 3 unknowns with 1 equation. And even not 2, because I might be able to reduce down to 2 unknowns, but that still won't let me solve it. So let's work on that chart. In our chart, we're going to have nickels, dimes, quarters. And the titles are going to be the same as what they were in the last chart. Quantity, so how many? That's what we don't know, so that's where N, D, and Q come. Value of 1. We wouldn't say price of 1 because that doesn't make sense. And here's where I see the biggest mistake. look at how your total is given to you in terms of dollars. So when you write the cost of your coins or the value of your coins, you have to do it in terms of a dollar. A nickel is 0.05, and I have a lot of people write it as 0.5, and that's why they get the mistake on this. Dimes are 0.10, or we could drop off that last zero, and quarters are 0.25. The total value for nickels would be 0.05 N, 0.1 D, and 0.25 Q. Now, they told us one other piece of information that dealt with total value. What was that other piece of information that mentions total value? Trent. Which is $4.50. So these together add up to equal the 450. So that's our first equation. 0.05 N plus 0.1 D plus 0.25 Q equals 450. Okay? All right, let's come up with another equation. Second sentence. He has 3 times as many nickels than dimes. So what does he have more of? Does he have more nickels or more dimes? More nickels. So that means nickels is by itself. How do I describe it if he has 3 times as many nickels than dimes? 3D, right? All right, let's keep reading. And the next part of the sentence says, and 4 more quarters than dimes. What does he have more of? He has more quarters. How many more quarters does he have than dimes?
4.
4. So it's D plus 4. What does this look like to you? This is a perfect one for substitution. So 0.05 instead of N, we write 3D. Plus 0.1 D. Plus 0.25, and instead of Q, we write D plus 4. All of that equals $4.50. Now we're going to run out of time on this problem, so I'm going to give you the answer right now, but I'm going to go back and finish it out before I upload the video. Actually, I don't have the answer right now. I'll have to do it later. Come back and watch, and you will see the end of the video. So I don't like the decimals, so I'm going to get rid of them. I'm going to multiply by 10, or 100, 100, 100, and 100. And that's going to give me 5 times 3D plus 10D plus 25 times D plus 4 equals 450. So I'm going to go and erase the chart and do the work up there so that we have more room. Since I don't want to go on to the next screen. These problems are so long. So we're going to take this and bring it up here. So now when I distribute, I get 15D plus 10D plus 25D plus 100 equals 450. So notice I have like terms here, and I'm going to subtract 100 from both sides to get the constants together. And I get 50D equals 350. Divide both sides by 50, and I get D equals 7. So there are 7 dimes. And then I'm going to take that answer and plug it back in here first to figure out the number of nickels. So nickels is 3 times 7, or 21. 21 nickels. And take that and plug it into this equation, and the number of quarters is 7 plus 4, or 11. And we have 11 quarters. And you can always check this. 7 dimes equals 70 cents, and 21 nickels is $1.05, and 11 quarters is going to give me $2.75. So when I add, I get the 450. So here we go.